But we're going to try to find the equation of the line tangent to the function h of x is equal to 1 over x plus 1 at x equals 2. So another way to write this function, which we'll need to do so it looks a little bit nicer, is writing it like this. So h of x equals 1 over x plus 1. Okay. For some reason, this ActiveInspire software doesn't allow me to write it like that, so I have to write it in. All right. So this example right here, we're going to look at this, and once again, add a value that I have right here, and I'm also going to show you a graph so that way you guys can see it as well. All right. So first thing we need to do, first of all, is we need to identify our a value. So in this case, we're going to say one of our important parts is a equals 2. Okay, that's where we're taking the tangent from. Okay, second is we need to find what f of 2 is going to give me. Okay, so in this case, it's going to be 1 over 2 plus 1, which is just, if we simplify, it becomes 1/3. Okay, that's one thing we need here. All right, so I'm going to just kind of shade in a box here to say, hey, this is an important thing that we need in order to figure this out. Third thing we need is, you probably guessed already, is f of 2 plus h, which remember, h is that little increment value in finding the tangent when h becomes really, really little, when it becomes close to 0. Okay. So here's what that looks like. It gives me 1 over 2 plus h plus 1. Okay. So that's going to give me, if we simplify and combine our like terms, that gives me 1 over 3 plus h. Okay, once again, put a little square there so we know to come back to it. All right. And so now what we need to do is we need to find the line, the slope of the line tangent to that value at x equals 2. So once again, we're going to use this formula, m tan is equal to the limit as h approaches 0 of this guy. So f of a plus h minus f of a, all divided by h. Okay? And we know that a is going to be 2, and we know, so basically if we were to simplify this, it would be f of 2 plus h minus f of 2, all divided by h. Don't forget to include your limit there. So limit as h approaches 0. We're going to continue on part 4 here. Let me just insert a page after here. Okay, so we're going to go ahead and replace our h values here. So that's, once again, limit as h approaches 0. So a plus h was, or 2 plus h was 1 over 3 plus h. And then minus our function value at 2 is 1/3. And that's all over h here. Okay, so I'm going to go ahead and I'm going to apply the concept of, combining two rational functions in the numerator here. So least common denominator between these two is going to be 3 times 3 plus h. Okay, so that means I'm going to multiply the first rational function by 3 over 3, and the second rational function, 3 plus h divided by 3 plus h. That's going to give me 3 over 3 times 3 plus h minus, and then going to be 3 plus h divided by 3 times 3 plus h. All right. So this is going to look a little weird for right now. Bear with me here, okay? Just going to get rid of that extra mark. I don't know why my board is acting up this much. All right, but now that these two have the same denominator, we can combine them. Okay, so we're still going to get the limit as h approaches 0. Let's see here. So if I subtract these out, this is going to become 3 minus 3. Now this minus goes with the h, so it becomes 3 minus 3 minus h all over 3 times 3 plus h all divided by h. All right, that's a lot of stuff right here, but we're going to go ahead and compress the denominator of what's on top here with the h here. And all we have to do to compress that is literally just move this into that part. So that way we're looking at just two separate entities of our rational function. So limit as h, which is 0, of, and then 3 minus 3, we'll just do that too. We'll kind of two birds, one stone. 3 minus 3 is 0. So we're left with negative h over 3h times h plus 3. Okay? Now, just like we saw in class today, we want to cancel out any common factors. And thankfully, it kind of works out for us because we have a common factor of h in both numerator and denominator. So these are going to cancel out. Because remember, factors are just numbers that are multiplied. So we factor that out. We're left, once again, limit as h approaches 0 of negative 1 over 3 times h plus 3. And once again, we cancel out the factor that would normally turn our denominator into a 0. Now we can just replace h with 0, and that'll give me negative 1 over 3 times 3, which is negative 1/9. All right, so there's my slope of my tangent line, negative 1/9. Okay. Okay. So now, let's turn another page here. Okay. So now, once again, we have a point that exists on our in our function, which is, let's see here, 2 1/3. So 2 1/3, and we also have the slope of the line tangent to it, which is negative 1/9. So now all we have to do is just use our point slope to find the equation of that line. Okay, so x minus x1. And that's going to give me y minus 1/3 equals negative 1/9 times x minus 2. Okay. And then I had to go ahead and do my negative 1/9. So y minus 1/3 equals negative 1/9 x plus, now negative 1/9 times 2, that's just 2/9. And if I go ahead and add 1/3 to both sides, I get y equals negative 1/9 x. Let's see here, plus, let's see here, 1/3 is 3/9 plus 2/9 gives me 5/9. And that's the equation of the line tangent to that rational function, 1 over x plus 1 at x equals 2. And I'll show you what I mean here by giving you guys a visual. If you look at the screen that I'm sharing with you, let me see if I can make this a little bit bigger for you. All right, so if you look at the graph right here, look at how the purple function is your rational function. Here's your tangent line in black. There's that 2 1/3. Notice how if we zoom in on this, notice how it only really meets that one point. So anytime you go, you really can't see it really up close, but you notice that it only intersects at one point and it doesn't go through the graph. That's how we know it's a tangent line. Okay, there's only one point of intersection and it stays on the same side of the rational function right here. Okay?